right, this is your captain speaking. So here I'm gonna cover learning activity 8 for you. Yeah, well, not learning activity 8, I mean 7. And I know I wrote 8, I meant to put 7, but whatever. All right, so for the first question, we're being asked to find the derivative of this function, y equals 1 over the square root of 1 plus x squared. Yeah, all right, so the general formula for Leibniz notation calls for dy dx times dy over du. Well, dy dx equals dy du times du dx. So with our given function, we're gonna evaluate u and y. So taking a look at our function, 1 over the square root of 1 plus x squared, our u is gonna be 1 over, 1 plus x squared. And our y is gonna be 1 over the square root of u, which in this case can be rewritten to u to the negative power of 1/2. So now under Leibniz notation, given that this is a composite function, this means that y is equal to f of g of x. If that makes sense, I don't really know, and if it doesn't, you can just rewatch Pedro, I guess. All right, so going back to our general formula, dy dx equals dy du times du dx, we're gonna solve first for dy du. So to do this, we have dy du equals d over du, and we're gonna substitute the y for u to the negative 1/2. We're gonna substitute our y for u to the negative 1/2. If I said u, then, well, we're substituting y because it's dy du. So in place of y, we have u to the negative 1/2. And so now we're finding the derivative of this function. So to do this, since it's a power rule, we basically move the 1/2 in front. So we have 1/2 u, and then we subtract the 1/2 minus 1, which is equal to negative 1/2 u minus 3 over 2, which, if this were rewritten in fraction form, can be written as negative 1 over 2 u to the 3/2 power. And if we were to simplify, all right, so now that we have this thing, negative 1 over 2u, 3 over 2, notice that I said that u is equal to 1 plus x squared. So in place of u, what we're going to do is we're going to substitute u for 1 plus x squared. So this renders us with negative 1 over 2 times 1 plus x squared to the 3/2 power. All right, so now we have dy du. Next thing we're going to do is du dx. So du dx equals d dx. So notice how in dy du, in place of y, we use u to the negative 1/2. Here, since we have du dx, we keep the dx at the same, and then in place of u, we substitute it for 1 plus x squared. So we have d dx of 1 plus x squared. And so now we basically just find the derivative of this function. So as you know, the derivative of a constant by itself is just 0, and the derivative of x squared is 2x. So here, d dx of 1 plus x squared is 2x. All right, now we have our du dx. So now that we have our dy du and du dx, we can now solve for dy dx. So what we're gonna do here is dy dx. So dy dx is equal to dy du times du over dx. So our dy du is -1 over 2 times 1 plus x squared to the 3/2. So I'm gonna write that as our dy du. -1 over 2 times 1 plus x squared to the 3/2 times du dx, which is 2x, so times 2x. And this can be simplified, so if we multiply 2x times -1, that's just -2x. Notice that the 2's right here cancel out, so these 2 cancel out. And therefore, that leaves us with -x over 1 plus x squared over 1 plus x squared to the 2 over 3 power, which can be simplified to -x over the square root of 1 plus x squared cubed. And this is our final answer for number 1. Yeah, all right. So this is how you solve this function using Leibniz notation. So if this is good, yeah. And if it seems like a little confusing, just like rewatch Pedro and yeah. All right, let's go to the next question. Number 2. All right. Notice this room is a little bit lame because there's only one board and it's not like the other room that had like the big board, but I'm kind of glad it doesn't because I failed at getting up yesterday. Feeling fat. All right, and yeah, I'm gonna fix this to 7. All right. So for number 2, we're being asked to find the derivative of this function, which is f of x equals arc cosine. Notice that this notation means arc cosine or inverse cosine. So arc cosine of 4x squared. All right. So under prime notation, this is a composite function. Our composite function is cosine of 1 over inverse cosine of x, and then our other function is simply 4x squared. So under a composite function, we know that y is equal to f of g of x. So in this case, our g of x is going to be 4x squared, and our f of x is going to be our cosine of u. So our cosine of u. All right. So now that we know all of this, under prime notation, the general formula is dy dx is equal to the derivative of, well, f of prime of g of x times g prime of x. So notice first that we're evaluating the outer function, and then we gotta go inside the inner function with respect to prime notation. So let's go ahead and evaluate our f of u for f prime of u. So in this case, our f prime u is gonna be equal to -1 over the square root of 1 minus u squared. Now, our f prime of g of x is equal to -1 over the square root of 1 minus g of x squared, which is going to be equal to -1 over the square root of 1 minus 4x squared, and I should put this in parentheses, squared. So 1 minus 4x squared, because this is our g of x. Our g of x is 4x squared, and the main function for this is, well, the derivative of our cosine is -1 over the square root of 1 minus u squared. And yeah, so when we plug in u for our g of x, we substitute g of x for 4x squared. So we have -1 over the square root of 1 minus 4x squared, because the general formula calls for u to be squared, and our g of x is 4x squared, so we're essentially squaring this whole thing right here. All right, and now for g prime of x, we're essentially just going to be taking the derivative of g of x. So in this case, the derivative of our g of x, which in this case is 4x squared, that's simply just going to be 8x. So it's 8x because 2 times 4, it's 8, and since this is a power rule, what we're doing essentially is we're multiplying 2 by 4, which is 8, and then we're subtracting 2 minus 1 because that's the power rule of derivatives. So that's our derivative for g of x, 8x. All right, and with that being said, now we can just substitute everything in. So what we're gonna do is dy dx is equal to minus 8x over the square root of 1 minus 16x to the 4th. Now, I'm sure you're wondering how the hell I figured this out. So dy dx is equal to negative 8x over the square root of 1 minus 16x to the 4th power. So as I said earlier, the general formula for prime notation calls for dy dx to be equal to f prime of g of x times g prime of x. So our f prime of g of x is equal to -1 times the square root of 1 minus 4x squared, and our g of x is simply 8 of x because we take the derivative of our g of x, which is 4x squared. Alright, so basically how I got this answer, our f prime of g of x is -1 over the square root of 1 minus 4x squared. So what we do, we take our f prime of g of x, and then we multiply it by our 8x. So notice that there's nothing in the bottom. This basically just represents 1. When we have nothing in the bottom, that just means 1. So right here, this is -8x over, we keep the square root. So this is just going to be 1. And then 4x squared, what this basically means is saying 4x squared to the 2nd power. And we can rewrite this as 4x squared times 4x squared. So 4 times 4 is 16, and then x squared times x squared is 16x to the 4th power. X to the 4th power, and this right here is our final answer. So minus 8x over the square root of 1 minus 16x to the 4th power is under prime notation. Yeah. All right, now we're gonna go to question 3. Question 3 has to do with a tangent line thingy, and I'm kind of sick of it. I know it's a lot of work too, and this one is a lot of work, but we'll push through. So yeah. All right, so for number 3, so we're given that f of 3 is equal to 4. And we're given that f prime of 3 is equal to 2. We're gonna set g of x equal to x squared f(3x), and we're being asked to find the equation of the line tangent to g of x at x equals 1. So as you know, the general equation for this is y minus y sub 0 is equal to m times x minus x sub 0. So our y0, what this is going to be, it's going to be our g of 1. The reason I say g of 1 is because we're given that the point where we have to evaluate the equation of the tangent line is equal to 1. So what we're doing essentially is we're just going to plug in 1 for wherever there's an x with respect to this function right here. All right, and our slope is going to be g prime of 1. So essentially what we're going to be doing for this is we're going to be taking the derivative of g of x, and we just plug in 1 once we figure out the derivative of this function. And our x0 is basically just 1. It's 1 because that's the point we're being given. So this is the x point that we're given. All right, let's begin. So g of 1, so we plug in 1 for x, so that's going to be equal to 1 squared f(3) times 1. This is equal to 1 f of 3, and with respect to the problem, f of 3 is equal to 4. All right, I should probably put 1 times f of 3. So this is just going to be 1 times 4, which is 4, and that's our g1. That's our y0. All right, now to find g prime of 1, what we have to do is we have to take the derivative of x squared f of 3 of x. So let's begin by taking the derivative of this function. Okay. And also we have to evaluate it at x equals 1 because that's going to be our g of 1, or g prime of 1, sorry. So right from the back we can tell that this right here is a product rule. So we apply the product rule of derivatives. So what we're going to do is we're going to take, I'm going to write it here at the bottom. I was going to write here, but there's not enough space. So we're going to take the derivative of x squared times f of 3 of x. So we have g prime of x is equal to the derivative of x squared times f of 3 of x plus x squared times the derivative of f of 3 of x. All right, so, and evaluate at x equals 1 because we're solving for g prime of 1 afterwards. So this is equal to 2x times f of 3 of x plus x squared times f prime of 3 of x, and that's the derivative of this function. So now we evaluate it at x equals 1. So now that we have the derivative of this function right here, what we're gonna do is we're gonna plug in 1 for wherever there's an x. So we have g prime of 1 is equal to 2 times 1 times f of 3. I'm not gonna put 3 times 1 because since we're evaluating x at x equals 1, I already know straightforward that it's f of 3, and I know I put right here 2 times 1, but why not? Plus 1 squared times f prime of 3. Alright, so this is 2, f of 3 is 4, so we have 2 times 4 plus 1 times f prime of 3, which is 2. So this is going to be 8 plus 2, which is equal to 10. Yeah. I'm just checking to make sure I did everything right, just that I didn't screw up. F prime of 3 is 2. Oh, right, I forgot the 3. I forgot times 3. Yeah, alright. Okay. Yeah, I forgot the 3 because we're using the chain rule to go inside. Alright, f of 3 of x times 3. Okay. Yeah, evaluate at x equals 1. So my bad for all of this. So yeah. Times 3. Okay. So this is just gonna be equal to 2 times 4. This is just 1. Alright, plus 1 times f prime of 3, which is just 2. And then times 3, so that's 2 times 3. 8 plus 6, which is equal to 14. Alright, so now we evaluated our y0 and our slope. We can now evaluate the equation of the tangent line. So we can begin plugging stuff in. So this is just going to be y minus g of 1, which is our y0, and our g of 1 is 4. So we have y minus 4 is equal to our slope, which is g prime of 1, which is 14, x minus 1. So we have y minus 4 is equal to 14x minus 14. To isolate y, we simply just add 4 to both sides. So we have y is equal to 14x minus 10. And that's our final answer. And that was number 3. Let's go to number 4. Alright, so for number 4, we have to use the chain and product rules to prove the quotient rule. In other words, we need to prove that y is equal to f of x over g of x. We need to prove that if y of x is equal to f of x divided by g of x, then dy dx is equal to f prime of x times g of x minus g prime of x times f of x divided by g of x squared. So essentially what we're going to be doing in this problem is we're going to be trying to prove that the quotient rule of derivatives corresponds to the end result of the function. All right, so this is essentially the same as saying, so the function that we're given is y is equal to f of x over g of x. This is the same thing as saying y is equal to f of x times g of x to the negative 1 power, which is how you would write it in exponential form. And then to find, now we would have to write the derivative of this. So in this case, we have y prime is equal to the derivative of, and notice that this is a product rule of derivatives as well. So what we're gonna do here is we have y prime is equal to f of x the derivative of f of x times g of x to the negative 1 plus f of x times g prime, well, the derivative of, g of x prime to the negative 1. All right, so we got this. Now, dy dx in this case, this is the derivative of this function. So dy dx in this case is going to be equal to f prime of x over g of x plus f of x times negative 1. And the reason I say f prime of x over g of x is because we're essentially rewriting this into fraction form. So this is f prime of x over g of x plus f of x times negative 1, because we're moving the negative 1, times g of x to the minus 1 because product rule, power rule of derivatives. And then this is all times the derivative of g of x. All right. So now we have that. What we have right here is we have f prime of x over g of x minus f of x times the derivative of g of x, so g prime of x, over g of x squared. See, I'm trying my best because Pedro did something like this. I can't explain it properly in Pedro's words, so I'm just gonna rewatch Pedro after this shit right here. All right, so now what we're gonna do is we're gonna multiply the numerator and denominator right here by g of x. We keep this side the same. So we have g of x times g of x, and then f prime of x times g of x. Therefore, with respect to all of this, this leads us to prove that y is indeed this leads us to prove that dy dx is in fact equal to f prime of x, g of x, minus g prime of x, f of x, all over gx squared. And that was number 4. I feel like this was a stupid question. All right. And for number 5, the final question, which is divided into A, B, C, and D. We're being asked to find the derivative of these logarithmic and inverse trigonometric functions. Gosh, this question was so confusing. All right, so for 5a, we have y equals 5 tangent, oh wait, so we have 5 to the power of tangent of 5x. And let me just recall something really quick right here. So, let me just re-clarify some things right here. So, the derivative of anything to the x, so say in this case we're doing 5 to the x, where our x is equal to 10 times 5x. So, the derivative of this thing would be like 5 to the power of x. We have d dx of 5 to the power of x. So any constant to the power of x, this is just going to be equal to the natural log of 5, so ln 5, times whatever is inside here. So ln of 5 times 5x. And let me also just re-clarify that the derivative of tangent of x is equal to secant squared x. So this is important to know. So the derivative of e to the x, where e represents a number and x is just like whatever's right here, is going to be equal to the natural log of the constant times whatever is inside right here. And then the derivative of tangent of x is equal to secant squared x. All right. Okay. So step 1, we have dy dx is equal to the derivative. So this is basically like the previous questions that we did. So our y in this case is going to be equal to 5 tangent, I'm using the finger like Mr. D. So 5 to the tangent of 5x. And yeah, so now that we have this, we're going to take the derivative of 5 to the tangent of 5x. So we have ln of 5 times 5 to the tangent of 5x times the derivative of tangent 5x. And the reason we have this is because under the chain rule, you have to go inside of the derivative. So obviously you can't, if you take the derivative of constant, that would just be 0, but you do have to take the derivative of tangent to the 5x with respect to the chain rule. Yeah, so now I'm gonna simplify this a little bit. So we have ln of 5 times 5 to the 10 of 5x. So the derivative of tangent is simply secant squared of x, so that's going to be secant squared x. And now we have to take the derivative of 5x, because once again we're going inside with respect to the chain rule. So right here, we have 5 so we got 5 ln of 5 times 5 10 of 5x times, oh yeah, I forgot the 5x right here, times secant squared of 5x. Okay, now that we have this, we can simplify this a little bit more. So we have ln of 5 times 5 to the power of 1 plus the tangent of 5x. And the reason I got this 1, 5 to the power of 1 plus tangent of 5x is because we take this here 5 and we can convert it into a 5 to the 1 power. So we would only have ln of 5 times 5 to the power of 1 plus tangent of 5x times secant squared of 5x. And just note that after this, I'm going to rewatch Pedro. And that was 5a. Let's go to 5b. All right, so for 5b, we've got f of x is equal to log base 7 of x e to the x. All right, so let me just clarify something really quick right here for you. So the derivative of a log function, so we have log base, like, say 7 in this case, because we're just representing this example. So the derivative of a logarithmic function, which in this case is d dx of log 7x, this is going to be equal to 1 over x times the natural log of 7. So 1 over x ln of 7. And since we also have an e right here, we have d dx of e to the x. That's just going to be equal to e to the x. All right, so let's get started. First things first, we have to find the derivative of this function. So we have f prime of x is equal to the derivative of log base 7 of x e to the x. Yeah. All right, so with respect to what I just said, what we're gonna do, this becomes 1 over xex times ln of 7 times the derivative of x e to the x. notice that we're using the chain rule. We take the derivative of this and then we have to go inside. So we take this and then we take the derivative of this. So we have 1 over x e x times ln of 7 times the derivative of x e to the x. So now, given that this is a product rule, we have f prime of x is equal to 1 over x e x times ln of 7 times the derivative of x times e to the x, and I'm going to continue like right here, plus x times the derivative of e to the x. All right, so here we have, once again, 1 over x to the ex times ln of 7, and the derivative of x is just going to be 1. So 1 times e to the x is just going to be e to the x. So we have e to the x plus x times e to the x, because the derivative of e to the x, as I said, is just e to the x. So now we basically just multiply. We basically multiply this by this. So this is going to be equal to ex so this is simply going to be equal to, wow, this is so confusing. Yeah. So we got 1 plus x times e to the x over ln of 7 times x e to the x. And notice that right here we can cancel out an e to the x. So we cancel an e to the x out from both. And we've got 1 plus x over x ln of 7. And that's our 5b. All right, let's go to 5C. I don't know how long this video is now. All right. So for 5C, we've got f of x is equal to the square root of x squared minus 1, and then outside of the square root, we have secant, arcsecant times x. All right, and let me just add a couple of more things for you. So the derivative of the square root of x is going to be equal to 1 over 2 times the square root of x, and the derivative of arcsecant that's going to be equal to 1 over the absolute value of x times the square root of x squared minus 1. All right, I know this is a lot of shit to remember. All right. So we can already take a look at the fact that this is a product rule of, this already is a product rule of derivatives. So what we got here is f prime of x is equal to the derivative of x squared minus 1 times secant, arcsecant of x plus, I'm going to continue right here, and the derivative logo right there, times, plus x squared minus 1 times the derivative of arcsecant of x. Yeah, so this essentially, this is just gonna, the derivative of x squared minus 1, this is just gonna be f prime of x is equal to 1 over 2 times the square root of x squared minus 1. And notice that we have to go inside as well with respect to the chain rule. So if we go inside, the derivative of x squared is just going to be 2x. And obviously the derivative of 1 is just 0. And this is all going to be times arcsecant of x. And I'm going to continue down here. Plus the square root of x squared minus 1 times the derivative of arcsecant of x, which is just going to be 1 over the absolute value of x times x squared minus 1. All right, so we can already denote several things. For starters, when we multiply the square root of x squared times this, we can denote that this cancels out, so x squared minus 1 cancels out right here. And we also denote that the 2's right here, they cancel out. So this cancels out and this cancels out. And that just leaves us with f prime of x is equal to x times arcsecant of x over x squared minus 1 plus 1 over the absolute value of x. And that's our 5C. All right, let's go to the last question, which is 5D. I'm gonna relook all of this over after this thing. All right, so 5D, we have h of x is equal to ln of x squared minus 1 over x squared plus 1. And let me add one more thing right here regarding the derivative of ln of x. So, right here. So a derivative of ln of x is going to be equal to 1 over x. All right. With that being said, let's jump straight into the problem. So right here, this is a quotient rule. This is a quotient rule thing. So what we're going to do first is we're going to take the derivative of this function. So this is going to be 1. Notice that we're finding the derivative of ln. So what we're going to do right here is 1 over x, and in this case, x squared minus 1 over x squared plus 1 is our x. So we have 1 over x squared minus 1 over x squared plus 1. times the derivative of x squared minus 1 over x squared plus 1, and this is all with respect to the chain rule. Alright, so now let's disregard this for now and focus on the derivative of x squared minus 1 over x squared plus 1. So we have d dx of x squared minus 1 x squared plus 1. Right from the back, we know that this is a quotient rule of derivatives. So what we have right here, we have x squared plus 1 times the derivative of x squared minus 1. Notice that I did it in reverse. This is basically the commutative property of multiplication that where it states that a times b is equal to b times a. So while the general formula calls for f prime times g of x minus f of x times g prime of x, I basically did it g of x times f prime of x, so I just used the commutative property of multiplication. And I'm going to continue this right here. So x squared plus 1 times the derivative of x squared minus 1 minus x squared minus 1 times the derivative of x squared plus 1 all over gx squared, which is going to be x squared plus 1 squared. So when we take the derivative of this, we have 2x times x squared plus 1 minus x squared minus 1 times 2x all over x squared plus 1 squared. So we can actually simplify this by factoring. So right here, 2x times x squared, that's just 2x cubed. So 2x cubed, and then 2x times 1, that's just 2x. And so right here, we have 2x times x squared, which is 2x cubed, but notice that there's a minus right here, so we have minus 2x cubed. And then we have 2x times negative 1, but once again, notice the minus, so we have 2x times minus minus 1, which is just going to be 2x. All over x squared plus 1 squared. So the 2x cubes, they cancel out. And we've got 4x over x squared plus 1 squared. All right, and now with that being said, we can now continue to solve. So I'm gonna continue right here. These are just derivatives. I'm just gonna continue right here. So we have h prime of x is equal to 4x over x squared plus 1 squared over x squared minus 1 over x squared plus 1. So now we're basically just going to be dividing fractions. So we know that when dividing fractions, we keep, change, and flip. So basically we have h prime of x is equal to 4x over x squared plus 1 squared times x squared plus 1, x squared minus 1. And so right here, since we have x squared plus 1 and then we have x squared plus 1 squared, we can just take out, we can just factor this out to x squared plus 1 times x squared plus 1. So this will cancel out, and then we're just going to take 1 away from here. So right here what we have is we have 4x over x squared plus 1, x squared minus 1, and we can also simplify the denominator by factoring. So we have h prime of x is equal to 4x over x to the 4th minus 1. Wow, it came out terrible. So we have 4x over x to the 4th minus 1, and this is our final answer. Notice that this right here isn't part of the work, the ddx over the ddx of like several functions. This isn't part of the work. I just wrote these out to like help you remember. Yeah, that was 5C and that was learning 5D and learning activity 7. So what I'm gonna do now is I guess probably just rewatch Pedro. Yeah.